Okay, so today we're going to start with At the Arcade. We are in Module 2, Topic 2, Lesson 2, At the Arcade. Okay, so right here we're going to start at the warm-up. It says use similar right triangles to determine the slope of the line. For this first line, A, see down here it says A. First of all, we know it's a positive slope. B, we know this is a negative slope. So first things first, so slope equals. Now I need to find where I have 2 points. I see a point here and a point here that I can use. Now, could I have picked other points? Could I have picked this right here? Sure, I don't care what you want to use. This is 1 high and it's 2 across. So the height over the base. Then I'll do the other one. So I'm going to use this right here and I'll use this right here. So this goes up 1, 2, 3, 4, 5, 6 times. This goes over twice. But remember on this one, it is a negative slope. That's not simplified, so I'm not finished. So that will get me -3. So the slope of line B is -3. The next page. Now, we're going to be identifying the graphs whose lines may have the given slope. Now, as you look at these down below, letter B down here should be the easiest one to do. This is a horizontal line. The only horizontal line we have is at C. Now, this little a down here, I don't know why they named him this way. So little a is 1/4. So that means going up and to the right. So that means D's not going to be my answer. B's not going to be my answer. So I know for sure that those two cannot be my answer. Now, A, E, and F could be depending on what the size or how much the graph goes up by vertically and horizontally. So this next one says 5/4. Again, it's positive, so it could be any of those. This one says negative. The only two that are negative are B and D. Okay, how do we do the estimation? Which ones were positive, which ones were negative, and then the zero slope. Okay, over here, it says Ron has a player's card for the arcade at the mall. His player's card keeps track of the number of credits he earns as he wins games. Each winning game earns the same number of credits. Make sure you understand that. Same number of credits. And those credits can be redeemed for various prizes. Ron has been saving his credits to collect up to 500 credits. The table and graph show the number of credits Ron has or had on his game card at various times today when he checked his balance at the arcade. Okay, so we're going to start there. So starting the day off, because we're talking about time, our number of games he's won. This says he's won 0 games. So that means that he had to have had credits from the day before, because this is talking about today. So he already had 120 credits right here. Okay, and then we have to figure out how much did it go up by every single time. So let's look at this. Number 1, is it proportional or non-proportional? So if it's proportional, we know it has to be a straight line, first of all. Then it also has to go through the point 0, 0. This does not go through the point 0, 0. So I just messed up, sorry. So this would be non-proportional because it does not go through 0, 0. Okay? The next one, the ordered pair, and we just talked about that. We talked about this right here and this up here. The fact that the day started and he had 120 credits because he has 120 credits from the day before. From the day before, he had 120 credits, or whatever day he went. Then it says use the graph to determine the slope of the line, then explain the meaning of the slope in terms of this problem. So I need to find out the slope. So it looks like it goes through right there, so I'm going to draw a line. Okay, now be careful with how much it goes up by. Yes, it looks like it goes up 1, 2. Yeah, it looks like that, but that's not what it is. Because if you look over here, 1 up is 40. So each time we go up, we're going up 40. So this is up 40 and another 40, so that's actually up 80. And how far over does this go? Well, this would be a 10 right here. So it's going, I don't know why. I know exactly why I wrote that. It goes over 10. So my slope for this is going to be 80 over 10, but we need to simplify that. And so down here, hopefully you figured out the slope the slope is 8. Remember, we have y over x, boys and girls. So the y is talking about the number of credits on Ron's playing card. So that means if this is 8 over 1, so he has 8 credits. And then on the bottom, it stands for the number of games won today. For each game won today. Okay, so he'll get 8 credits for each of the games he wins today. So over here, we're going to analyze Rhonda's reasoning and explain why her reasoning is incorrect. It already tells you that it's wrong. It already tells you it's wrong. Rhonda says that it's 440 over 40. Okay, so 440 over 40. So what she did is she took the y and she put it over the x. That means it's proportional. Guys, we already said this isn't proportional. It doesn't go through the point 0, 0. So we can't do that. When you get it, we get the slope is 11 because we're not going through 0, 0. This is not proportional, so you can't set up proportions. Okay? This is not proportional. So you can't do y over x. Okay, before Ron started winning games today, how many games had he won for which he had saved the credits on his player's card? Well, we know that he has 120 credits, right? We know he has 120 credits. Okay, we know that we get 8 credits for each game we win. For one game. We want to know how many games he's won. So if I cross multiply, I get 8x equals 120. I divide by 8 on both sides, and x equals, somebody can tell me, no, because you're not here, that would come out to 15 games. So he would have already won 15 games on a prior visit. Now, after Ron won his 40th game today, how many more games does he need to win to collect a prize worth 500 credits? Okay, so we know, that he currently has 60 credits. Sorry, after his 40th game. I don't even know what I was writing down 40 or 64. So after his 40th game today. So we have 8 We multiply that by 40, plus you have to remember he has 120 credits already. So that's 240 plus 120, that's 360. So right now he has 360 credits after his 40th game today. But he wants 500 credits. So 500 credits minus 360 is going to get us 140 credits he needs. So 140 credits. So I divide that by 8. And, uh-oh, what did I just do? I don't know what I did. There we go. It all of a sudden started moving on me. Okay, 8 goes into that. Did I do this? Did I do that right? After he won his 40th game today, how many games does he need to collect 500? So how many more games does he? 17.5 is what I got. Did I do that right? So after his 40th game, each game is worth, oh, it's because I multiplied wrong. I knew something was awry. Look at this, boys and girls. I don't know how to multiply. That's why I really need you guys here. It's because I need somebody to check my work. Okay, so that would be 440. That looks much better. Okay, I knew something was awry, but I couldn't figure out what. So 500 minus 440, that would get me 60 credits he needs. Okay, so he needs 60 credits, but it's asking how many more games. So I need to take that 60 and divide it by 8. That's where I was going awry. Okay, so 60 divided by 8 will come out to 7.5 games. So basically, he needs 8 games. Awesome. Okay. So, summarize what you did. We're going to skip that part, and we're going to come down here. So far, you have determined the rate of change from a graph using similar triangles and writing a ratio for the vertical distance to the horizontal distance. However, you can determine the rate of change or slope from a table. So the first thing it says is to choose any two values of the independent variable. Now, remember that independent are your x values. So I don't know. I don't care which one we use. I'm just going to use these first two because that's just easiest. So I'm going to write 12 minus 0, so that gets me 12. Then it says calculate the difference with the corresponding. So I need these, but I need to go in the same way I did here. So see how I did 12 first and then 0? I need to do the 216 minus the 120. If I do it the other way, it's not going to work. So that's going to get me a 6. Sorry, I did something else for a second. That's going to get me a 6. That's going to get me a 9. Is that 96? Yeah, it's 96. Okay. Then it says write a ratio. Down here it says write a ratio where the dependent, so I'm going to write the dependent, which was 96, and I'm going to write that over the independent, which is 12. And then I'm going to write it as a unit rate. 96 divided by 12, guess what, is 8. So 8 credits per game 1. Now, isn't that exactly what we just did on the other page. But this way, we learned it a different way. Okay, so what you're supposed to do on this next page, okay, is it gives you 3 examples here. Now, follow the arrows to calculate the slope. Was the slope calculated correctly in each case? And explain the errors. So I'm going to look at this. Remember, the dependent is on the top. So 440 minus 120 and 40 minus 0. So when I do that, I should have done this up above, but that's okay. So I'm going to get 0, I'm going to get 2, I'm going to get 320 over 40. That gets me 8. Oh, I came up with 8, just like I had done before. This one's going to be a little more squishied. I'm going to put it right here. So here, I'm going to get 40 minus 25. Can you see this minus sign? This one says to start here and go to here, so I'm going to do 320 minus 440. So when I do that, I'm going to get 15 on top and I'm going to get 120 on the bottom. That is not going to that would be negative 120. That would not simplify to 8. So we did something wrong there. So let's look at this one. It says, oh, I did 2 things wrong here. I would love for you guys to be able to yell at me and say, Miss Grandpa, you don't know what you're doing. Didn't I put the independent on the bottom or on top instead of on the bottom? It's supposed to be 320 minus 440 on top. I did it backwards. And then 40 minus 25. There we go. That looks a little bit better. It's still going to come out wrong. 120 over negative 120 over 15. That comes out to negative 8. That does not come out to positive 8, so it is not the same. There is an issue with that one, other than my incorrect way of doing it. Then over here, I'm going to take 216. I'm going to subtract 264. I'm going to take 12, and I'm going to subtract 18. When I subtract those, hopefully you get negative 48 on top and negative 6 on the bottom. Negative divided by a negative is a positive 8. So the only difference between the ones that came out correct and the ones that came out different, hopefully you notice this. Do you notice the direction on this of the arrows? They're going in opposite directions. You have to make sure that you're going in the same direction in order for it to work. So if we had done this middle one, example 2, with the 25 first, then the 40, then we would have come out with the right answer. Okay, so I did this without telling you I did this. There is a formula, there's a formula for slope, and it's y2 minus y1 over x2 minus x1. All this means, boys and girls, all these x's are these little numbers right here that are on that. It just tells you these two are coming from the same point. They're coming from the second point, okay? And these two, they both have 1s. It's coming from the first point. That's all it means. It means that you have to be coming from the same point. So let's go down here. And we can look at what they did. So we have this first point right here, 12, 16. Where did we get that? From right here. Then the second point was 25, 320. That's right here. Okay, so all they're doing is subtracting the y values over subtracting the x values. That's all they've done. So we're going to do the same thing. Okay, we're going to try this again. But we're going to do it for two different ones. So I'm going to use 0, 120 and 18, 264. Okay, so my slope is going to be, I'm going to take 264, that's my y value, and I'm going to subtract 120. So I took it from the second point, did the second point minus the first point, the y values. Now I'm going to do the same thing with the x values. Since I used 264 first, that means I have to use 18 first, and then the 0. So when I subtract that, I get 144 over 18, and that will get me 8. Now, does it really and truly, it does not matter which ones you use. So over here, I don't know, I'm going to use, let's see, I'm going to use 18 and 264 and 40 and 440. It doesn't matter which ones you use. It should be constant because it's a constant rate of change. So I'm going to take 440 because that's from the second point. I'm going to subtract out 264. Then, since 440 was used first, I have to use the 40 first and subtract out the 18. Now, 6, you guys, it would help if I had done these first. Okay, let's use a calculator so I don't mess up on it. Minus 264, and I get 176. I was on the right track. And then 40 minus 18, 22, and 176 divided by 22 amazingly gets me 8. So every single time I do this, I'm going to get 8 for that one. Okay? The next question asks, how is using the slope formula in the slope formula given a table related to using similar triangles on a graph? So let's look at this. When we had the similar triangles on the graph, where are we? Where's my graph? Guys, if you look at it, we started at 200. We started at 200 and we came down to 120. So 200 minus 120 over, because we started at this point up here, the x value for that point is 10. The x value for this point over here is 0. So I would get 80 over 10, which are the numbers that we had just a moment ago. Okay. So we're going to come over here. Calculate the slope for each linear relationship using the formula. Okay. So I'm going to come over here and I'm going to use slope. Doesn't matter which one you use. So if I did 12 minus 9 and 8 minus 4. So that would get me 3. That would get me over 4. Now, could I have used a different 2? Yeah, sure, why not? Let's use 30 minus 12. And because I used 30, I would have to use 32 minus 8. So this would get me 18 over 24. 6 goes into both of those, so I would still get 3/4. So my slope for this one is 3/4. Over here, again, I have my slope. I'm going to take -2 minus 13. Why did I pick those two? Because they're the first two. It doesn't matter. Now this is where you have to be careful. Because I used -2, that means 0 has to come first, minus, but that says -1. So I need to make sure that the minus and the -1 are two different things. So I get my slope on this negative 15 over positive 1, so my slope is negative 15. Now we can use a different 2, that's fine. How about negative 62 minus a negative 2? And then 4 minus 0. So this would get me negative 60 over 4, which is still negative 15. Okay. This one. I don't know. 23 minus 25. Since I used 23, I have to use 8. So that would get me negative 2 over 1, which is negative 2. Or I could have done the last two. I don't care. So 19 minus 21 over 10 minus 9. That would get me negative 2 over 1, which is still negative 2. It doesn't matter which one we do. This one, my slope, 9 minus 9 over 18 minus 7. 0 over 11 is still 0. All those numbers are the same, so the numerator is going to be 0. This is a horizontal line. It's a horizontal line because remember, if we have 0 as a slope, the line is horizontal. Okay, so here down here, again, we take our y values. So I take my second y, I subtract my first y. I take my second x, I subtract my first x. When I do that, I should get 15, and then 55 minus 10 should get 45. 15 goes into both of those numbers, and I should get 1/3. Next one, again, I take my second y, I subtract my first y. Take my second x and subtract my first x. 3 minus 19 would get me negative 16. This would get me 20. So my slope, let's see, 4 goes into both of those numbers, negative 4/5. Okay. So we're looking at number 1, and it wants to know which ones are proportional. So guys, if it's proportional, that means if it's proportional, we can do y over x. So let's look at number 1. If I do number 1 and I do 9 over 4, is that the same thing as 3/4? No, letter A is not. So then I do 13 over negative 1. Is that the same thing as negative 15? No. Then I do 25 over 7. Is that the same thing as negative 2? No. If I do 9 over 7, is that the same thing as 0? No. So none of these are going to be proportional. Now, we need to complete these with the words positive or negative. So if the slope of the line is positive, so that means it's going this direction, then the x value increases. So as the x goes this way, the y goes this way, so the x increases. Oh, I hate when I do that. Okay. And I have been talking about that if you've been paying attention. So this one, we have negative direction. So as the x's get bigger, the y's are actually going downhill. They are decreasing. The y values decrease. Okay, so now we want to look at these two. If you look at these two, you'll notice in the first table hopefully you notice in the first table, all of the x values are exactly the same thing, okay? They're exactly the same thing. So if I was going to draw this, and I'm just gonna, so 1, -5 is gonna be down here, 110 is gonna be up here, 115 would be up here, 130 would be up here. If I connected those, it's horrible, but if I connected those, I would have a vertical line. And all vertical lines have a slope of undefined. Okay? Why, you say? So let's look at this. If I did 15 minus 10 over 1 minus 1, so I get 5 over 0. 5 over 0 does not exist. You do not know how to even deal with that. This is, no, that can't exist. That's why it's undefined. Anytime you have 0 in the denominator, you get undefined. Whereas if I look at this, oh, and also notice, anytime you have a vertical line, it's going to be x equals whatever number. If you notice, the x values were all 1s. Over here, it says y is equal to 2. All of the y values are 2. So if I was going to draw this one, I would have 5, 2, I would have 6, 2, 7, 2, 8, 2. This is going to get me a horizontal. Ooh, that was horrible. So horizontal lines have a slope of 0. Now, we've already talked about that. But what we didn't talk about, what this is new and important information, is anytime you have a horizontal line, it will be y equals a number. Anytime you have a vertical line, you will have x equals a number. Super important. Super important. You must know that. Horizontal line is when it says y equals a number. Vertical line is when x equals a number. Okay? Now, next page, we already answered those questions down there. Now, you previously used similar right triangles to show that if the line given on a graph, then the slope is the same between any 2 points on the line. Okay, so that's important to know. I know you're like, why are you reading that to us? But this is important. The slope is the same between any points on the line. It has to be the same. In order for it to be a line, it has to have a constant rate of change. It has to be exactly the same. So the converse, so the opposite of that is true. If the slope between every ordered pair in the table of values is constant, that means we have to find out if we have a line. Then the ordered pairs form a line. So what we're doing right now is deciding, do we have a line? That's what we're trying to decide right now. Do we have a line? We don't know if we have a line yet. We have to figure out if we have a line. So we have to figure that out. So if I use the first two, I would get 28 minus 13, and I would get 9 minus 5. So when I do that, I get 15 over 4. Is that right? 15 over 4? Or do I not know how to? Oh, it helps if you write down the right number. I'm like, why is it over 4? We're usually pretty good. That's a 4 there. This is supposed to be the 5, and it comes out to 3. Okay, so let's check the next two. Let's check these two. So then I have 34 minus 28 over 11 minus 9. So when I do this, and I'm like supposed to be Johnny on the spot with my math, and today is not that day. So I have 6 over 2, which again gets me 3. Okay, let's check the last two. Okay, so the last two, I have 47 minus 34, over 16 minus 11. So my slope is 47 minus 34. I get 13. Is that right? I get 13 when I do that? Yes. And then I get 5. 13 divided by 5 is not, this is not equal to 3. So that means because of this point down here, those are not all on the same line because they do not have the same slope. They do not have the same slope, therefore they are not on the same line. They are not on the same line. No, they do not have a constant rate of change. Now, if we didn't have that last one there, the 1647, then we would have been okay. So now let's look at number 2. It says determine whether the ordered pairs, if they make a straight line. So we have to do the exact same thing we just did. So we're going to use the first two. So 13 minus 7 over 6 minus 2. 13 minus 7 is going to give me 6 over 3, which gets me 2. Then I look at it as 16 minus 13 over 8 minus 6. Sorry, I have a glare. So that gets me 3, that gets me 2. Did I do something wrong? Yeah, I don't know how to subtract. Again, don't know how to subtract. This would have gotten me 4, wouldn't it? So wouldn't that be 3 over 2? Whew! Almost messed up there. Well, I did mess up. Now I'm going to do this last one. 34 minus 16 over 20 minus 8. I would get 18 over 12, which simplifies the 3 over 2. So yes, this is a line, and its slope is 3 over 2. So let's look at this one. Now I'm going to teach you something, so you don't have to actually write out all of that. What's the distance between these two? 7, 7, 7, 7. The distance between these two, 1, 1, 1, 1. If I wrote these all over as ratios, wouldn't I get 7 over 1 each time? So therefore, I have a straight line. Okay, let's look at the next one. Okay, now look at these. These next ones. When the values of the independent variable in a table are consecutive integers, like the one we just did, don't you just have a 1 on the denominator? So it makes it really simple if we're going up by ones. If I go up by ones, my denominator is 1 every single time. Okay, so this is called the first differences, and it just means that your table goes up by ones. Okay, so if this goes up by ones every time, that means that we're dividing by 1 each time. So if I look at these, 34 are to go from 25 to 34. Why am I using that? So 34 minus 25 is going to get me 9. And then 45 minus 34, I'm making sure I've got the right thing. Oh, whoa. Those are two different numbers. So I know right now, I don't even have to go any further, that this is not a line. Okay, so let's go over here. These again are going up by 1. So I'm already going to divide by 1. So that's easy peasy lemon squeezy. Now be careful here, because we're not going up, we're going down. So 8 minus 12 is actually going to get us negative 4. 4 minus 8 is going to get us negative 4. 0 minus 4 is negative 4. Negative 4 minus 0 is negative 4. So on this one, yes it is, because we have a slope of negative 4. It's negative 4 over 1, but it's okay to not write the 1 on the denominator. So again, this one's going up by 1s. So all I have to do is look at the change in y. So 4 minus 1 is 3. 9 minus 4 is 5. Oh! Not a line. Okay, my slopes are not the same. Again, this is going up by 1. Isn't it awesome when they're going up by 1? Okay, so if I subtract these, I would get 3, 3, 3, 3. So yes, it's a line in this. Oh, that was weird. Yes, it's a line, and my slope is 3. Okay, I hope that helped you. If you have any questions,